Hi, I'm Vicky, and I'll be presenting Deformable Sprites for unsupervised video decomposition. When we look at this video, we don't see a sequence of independent frames, but a bear moving in its environment as the camera pans. Our goal is to decompose this video into a more structured representation, consisting of these underlying elements. Given a video, we want to find the instances of each moving element in the scene and relate them together with a global representation. Inspired by classic works, we represent the video as moving image layers, or sprites. This layer decomposition not only enables automatic segmentation and long-term tracking, but also consistent video editing of articulated objects such as this bear. Prior works have explored this task of video decomposition for editing applications, but many rely on input masks of the objects of interest, either from semantic segmentation models or the user. This makes it difficult to handle video objects that do not fall into common semantic categories. Moreover, object grouping depends on the context of the video, and semantic masks might require additional input to specify a natural grouping. We aim to solve the joint problem of both detecting and estimating the moving layers in an unsupervised way. To do this, we introduced Deformable Sprites, a layered video representation. For a video, we accumulate the appearance of each scene element into a shared texture image, or sprite. At the same time, for each video frame, we find instances of each sprite, and map each instance into the sprite's UV coordinates with non-rigid transforms. We relate each instance of a layer to the global sprite image using a spatially smooth, low-dimensional function. We then use this function to remap each layer's appearance from the sprite. We also model the entire video as a temporally smooth trajectory by keeping a small set of keyframes that we interpolate between. We then reconstruct the input frame with our representation and optimize the reconstruction loss. Because this problem is underdetermined, we add motion-based priors to guide the mask grouping and transform fitting. Please see the poster for more details. We now show some video decomposition results. We decompose this video into two layers. Notice how our transforms consistently track the elephant as it moves in the middle row. In this video, notice how we unwrap the background as the camera pans in the bottom right. Our unsupervised method is less constrained by mask requirements and performed well on diverse internet videos. In this video, the Earth rotating in 3D is unwrapped into a map of the world. For these videos, we also show semantic segmentation masks for reference. We decompose this video into one of a snail moving across grass. We also show decompositions for scenes with multiple foreground objects. Here, the bee and flower are separated by small motion cues. We omit the background layer. Here, we separate the skaters from each other and their shadows. When we specify the number of layers differently, our discovered grouping remains consistent. Here, we show this video with 4 natural layers: the fern, 2 parrots, and a background. When we specify 3 layers, the fern and background are separate, though the 2 parrots are grouped together. When we specify 4, the 2 parrots are separated, the fern and background remain the same. And when we specify 5, the same grouping remains. No group becomes over-segmented. We also evaluate the output masks of our representation against unsupervised segmentation baselines. Because our method estimates the texture image for each layer, our segmentations are more consistent over the entire video when compared to baselines. Our deformation model also helps the masks capture articulated motion, such as the legs of the camel, compared to the baselines. Our method performs as well as current state-of-the-art on common benchmarks. Finally, we demonstrate video editing applications using our decomposition. By directly editing our sprite images, we can consistently propagate edits across the entire video. Here, we add edits to both foreground layers that are consistent with occlusion. We can also modify the background image, for instance, with style transfer. And also add stroboscopic effects to the moving foreground. Thank you for your time. please visit our poster and website.